Let's go over a practice problem for this week's discussion quiz. Given this function f of x, a polynomial, we'd like to use the limit definition of the derivative to find f prime of x. So you have to know this definition. I'll state it first. The definition is that f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. So definitely know this definition and then also state it on the quiz. Now we're going to have to cube and square both x plus h. So left some space up here where I'm actually going to write out what both of those things are equal to. So if you have x plus h and it is squared, you square the first term, the x. You square the last term, which is the h, and you'll always get 2 of the middle terms, x plus h. The rule for cubing is similar if you have x plus h cubed. You have x cubed as your first term, then you have 3 times x squared times h to the first for the next. Then you have 3 times x to the first, but h is squared, and then simply you have h cubed at the end. So knowing both of these is a good idea. So continuing with the limit definition of the derivative, we have that this is all equal to the limit as h goes to 0 of, okay, f of x plus h means put an x plus h into all the x's. So that is 5 times x plus h cubed minus x plus h squared plus 4. Next, we are subtracting f of x, and I want to be careful to use parentheses here. We're subtracting the entire function f, which means 5x cubed minus x squared plus 4. This is all divided by h. Okay, next I'm going to expand this and this expression by using these identities up here. I'll also distribute the negative to all 3 terms from here. So the next line is, this is the limit as h goes to 0 of, it's going to be quite a long line, but we have 5 times, okay, x plus h cubed is x cubed plus 3x squared h plus 3xh squared plus h cubed. Then it's going to be minus x plus h squared is x squared plus 2xh plus h squared. Then there's a plus 4, and then we're also going to subtract 5x cubed. We will add x squared and subtract 4. And this is all divided by h. For the last step, I'll distribute the 5 into here and the negative into here. I guess it won't be the last step, but it's going to be the last hardest step of this. Okay. So this is the limit as h goes to 0 of, again, we're going to have a lengthy fraction. This is 5x cubed plus 15x squared h plus 3, not 3, that's not correct, plus 15xh squared plus 5h cubed. Okay, I'll change the sign on all of these terms as we distribute the negative. So that's minus x squared minus 2xh minus h squared, and then there's a plus 4. And then I already distributed the negative on the negative 5x cubed plus x squared minus 4. This is all over h. Okay, in this step I can now cancel a whole bunch of stuff. For example, I have a 5x cubed and a minus 5x cubed. That cancels. Okay, we also have this minus x squared and this plus x squared. And I think there's one other thing. Oh, this plus and minus 4. Everything else that remains has a factor of h in it that we can cancel. So we're getting close to the end. This is the limit as h goes to 0 of, okay, so we have 15x squared h plus 15xh squared plus 5h cubed. Okay, then we have minus 2xh and minus h squared. Okay, that's everything. That's all for h. So I'm going to move on to another slide, but from this step here, every term has at least one h in it. I'm going to factor it out, cancel with this h, and then I'll be allowed to put 0 in everything of the h's that remains. Okay, in this next step, this is the limit as h goes to 0 of, so I'm going to factor out an h from every term. So let's see, that's going to be h times. Okay, so here it's only going to be 15x squared that's left over. The next term is going to be 15x and only a single h remains. Then we'll have 5h squared minus 2x and then minus h squared. And this is all over h. And the reason for this is this and this can cancel. In fact, the entire denominator is now 1. We don't even need to write it. I'm just going to write down the limit as h goes to 0 of what's left over in parentheses. 15x squared plus 15xh plus 5h squared minus 2x minus h squared. By direct substitution, if we put 0 in place of all of the h's, okay, that's 15x squared plus 15x times 0 plus 5 times 0 squared minus 2 times x minus 0 squared. And that means the only terms that remain are the 15x squared, because this is 0, that's 0, and we have a minus 2x. So the answer to this question is the derivative of the function we started with is 15x squared minus 2, and I left off the x. It should be 2x, and this is it.